So let's look at graphing accelerated motion. Now we're going to use this motion of a bicycle graph, this velocity time graph, to look at this accelerated motion. If an object has a constant acceleration, then the velocity time graph has a straight line. Much like this picture, we have a straight line. And from that straight line, we can find the slope. And the slope of a velocity time graph is the acceleration of the object. And that's the important piece here. We found slope of graphs before. This slope is going to be the acceleration when we have a velocity time graph. And the other thing that's different about these graphs is we can actually find displacement by finding the area under the graph. So we're going to be doing some area calculations as well, and that'll determine the displacement. So if we were calculating the area of this graph, the displacement is the area. This is a rectangle, so area of a rectangle is just length times width. It doesn't matter which one we call length and width. We can take our length as 8 meters per second multiplied by 20 seconds, our length times our width, sometimes base times height, doesn't really matter. And when we multiply those together, we'll get 160 meters. And if we look on the graph, it's pointing in the east direction. Because we're dealing with displacement, we need a direction. It's 160 meters east. So pretty straightforward if we have a rectangular graph. But what if we have a graph like this? And even if the velocity is not constant, meaning the velocity is changing, the area still represents the displacement. We'd still have to find the area under that graph. This time, though, we're dealing with a triangle. And as we probably remember, area of a triangle is just base times height times 1/2. Well, if we look at this picture, our displacement can be calculated finding 1/2 times our base, which is 10, our height, which is 8 meters per second. Fire those all in a calculator, and this time we'd get 40 meters, again, east. Displacement given a direction. Just finding the area of that triangle. We may even have a graph like this one, motion of a dog. And this graph actually goes below 0 in the velocity. And remember, if we have a negative velocity, this is just going to have a value that's in the negative region. That's okay. If a portion of the area is below the axis, we just consider it negative displacement. And the displacement is found just by adding the two regions together. So if we look at displacement, we find the top region, and that's just a 4x3 rectangle. The bottom region is just 4x3 as well, but this time it's in the negative velocity, so we have a negative 3 meters per second times 4 seconds. Multiply those together, we get 12 meters and negative 12 meters, and in the end, we add them together, 12 plus negative 12, we just get 0 meters east. So we just find the displacement above, subtract the displacement below, and we'd find our total displacement. And that's going to allow us to find displacement, velocity, and acceleration all from the graph.